Hello everyone. Today I am here again with another chapter which is circle, and in this chapter we are going to discuss about first of all the basic concepts related to the circle. Then we'll be talking about the theorems of circles, and finally we'll be discussing the problems based on circle. So let's start with the definition of the circle first of all. So what is circle? So a circle is a collection of all the points in a plane which are at a constant distance from a fixed point. Here, the fixed point is called center of the circle and the constant distance is known as the radius of the circle. So in this case, we can say that the fixed point is known as center of the circle and the fixed distance, or we can say constant distance, is known as the radius of the circle. Moving to the next point. Next, let's talk about circle and a point. So here we'll be talking about the location of a point with respect to a circle. So when we place the point in a plane with respect to a circle, then a point can lie at the three different places with respect to the circle. That will be interior to the circle, exterior to the circle, and on the circle. So in this case, if you will check, let us take a point P, point Q, and point R. Considering the rectangular region as a plane, we can say that point P lies interior to the circle, point Q lies on the circle, and point R lies exterior to the circle. That means we can say here that this is exterior of the circle, this is interior of the circle, and then there is a point which is called on the circle. So this is how we can locate a point with respect to a circle. Moving to the next point, we'll talk about circle and a line. Now when there is a circle and there is a line, again there are three different possibilities are there. The first possibility is the line is neither touching nor intersecting the circle. Second point is where the line touches the circle. So at this point we can see the line is touching the circle. So the line is called here tangent. And the point where it touches the circle is called point of contact. Then the third case is where the line is intersecting the circle at two distinct points. In that case, we can say that this line is secant of the circle. So tangent is a line which touches the circle at one point only. Secant is a line which intersects the circle at 2 points. Moving to the next part. So next let's talk about the tangent. What is tangent? A line which touches or intersects a circle at one point only. So if we'll take a circle and a tangent. So in this case, the point A, here A is known as point of contact, and we can say BC is the tangent. Let's talk about one more point which we have seen earlier, that is a secant. Now what happens in the case of secant, that when you move this line with respect to a circle, then we can say there is a time when the two distinct points will coincide, as in this case, and so the secant will become the tangent. So what we can say in this case, that the tangent is a special case of secant. And in that case, what will happen if I am taking this point as A and B? So for this secant to be the tangent, the point A and B will coincide. Or another way you can think of, that if you draw a secant from a point, and then further we know that from a point infinitely many lines can be drawn. So in that case, while drawing such lines, we'll have a line which will be a tangent. So what we observe here is that if the point is exterior to the circle, we can draw two tangents to a circle here, if you observe closely. Because one tangent here, it will be PC and the other tangent will be PD. Let's talk about the next, which is the theorem. And here we'll be discussing about the first theorem that says that the tangent at any point of a circle is perpendicular to the radius through the point of contact. So to prove it, so given is AB is a tangent. Here we have to prove that OP is perpendicular to AB. That means we can say that we have to prove that angle OPA equals to angle OPB, which is equals to 90 degree. Now to prove it, we'll do a construction that will be, take a point Q on AB other than P. So if we'll take a point Q on AB other than P and then join OQ, which intersects the circle at R. So in this case, what we observe is that if you'll take OQ, we can write it as OR plus RQ, which is equals to R plus RQ. And so we can see here OQ will be greater than radius. That will be true for any point which is on line AB other than P. So we can say that which is true for any point Q on AB other than P. Therefore, we can say that OP is the shortest distance of O from AB. And we know shortest distance is a perpendicular distance. So we can say that therefore OP is perpendicular to AB. And this is how we can prove this theorem. Moving to the next part, we'll talk about the number of tangents from a point. So as we have seen what is tangent, let's talk about how many tangents can be drawn to a circle from a point. So when a point lies in a plane with respect to a circle, We have also seen that where the point can lie. Either the point will be inside the circle, on the circumference of the circle, or exterior to the circle. When the point is inside the circle, so in that case, suppose if you will take the point P, so what we observe is any line passing through this particular point will intersect the circle at 2 points. And so in that case, the number of tangents will be 0. So here, number of tangents will be equals to 0. Moving to the next case, where the point lies on the circle. So if the point lies on the circle, then we will be able to draw only one tangent, because any other line drawn through this point will be secant to the circle. So if the point is on the circle, we can draw only one tangent. So here, number of tangents will be equals to 1. And now the last case, where the point lies exterior to the circle, in that case, we will be able to draw two tangents. So that is, if suppose the point is here, and if you are drawing the tangent from this point, so here the number of tangents will be equals to 2. So we can see from here that if it is about a point, then we can draw at most two tangents to a circle. And in that case, the possible number of tangents are, it will be either 0 tangents or 1 tangent or 2 tangents, based on whether the point lies interior to the circle, on the circle, and exterior to the circle respectively. Then one more point we need to remember, that as a note, there can be infinitely many tangents drawn to the circle. So when we do not talk about the point, then we can draw infinitely many tangents to the circle, as a circle is a collection of infinitely many points. And so on each of those points we can draw a tangent, and so there are infinitely many tangents exist on a circle. But when it is about a point, then it will be specific to 3 different situations which we have seen earlier. Moving to the next case, we'll talk about some of the terminology which will be involved when a pair of tangents are drawn from a point. In this case, if you see here, PA and PB are two tangents. Another case is if you talk about this particular angle. So here, angle APB is known as angle between the tangents. Here the point A and B are point of contacts. Another point, here in this case, we can say that PA and PB are known as length of tangent. So what is length of tangent? So length of tangent is the line segment joining point of contact to the point from which the tangent is drawn. So these are some of the terminology which is related to the circle, that is point of contact, length of tangent, angle between the tangents, and we will be using it very frequently while solving the questions. Let's talk about the next, where we'll be talking about the theorem. The theorem says that the length of tangent drawn from the exterior point of a circle are equal. So in this case, it is given that PA and PB are two tangents. We have to prove that PA equals to PB. In order to prove that, we'll join OA, OB and OP, where O is center of the circle. So what we observe here is, if we'll take in triangle PAO and triangle PBO, we'll get OA equals to OB, that is radius. Then OP equals to OP, that is common. And we'll also get angle OAP equals to angle OBP, that is angle between the radius and tangent is 90. We have already seen in the previous theorem. So therefore we can say triangle PAO is congruent to triangle PBO by RHS criteria, and so we can say that therefore PA equals to PB by CPCT. That means corresponding parts of congruent triangle. And this is how we can get this result using congruency concept. Moving to the next point, where there are some more useful results which are associated with this theorem, and it can also be asked as a question, that says that if you draw two tangents to a circle, then the first case is they subtend equal angle at the center. Moving to the another point which gives a useful information about a type of quadrilateral which we draw the two tangents and also the opposite angles of that quadrilateral. So here we are talking about the quadrilateral AOBP. If you see here, we can say in quadrilateral AOBP, we know angle A equals to 90 degree and angle B is also 90 degree, which is angle between radius and the tangent at the point of contact. Now what we can say from here, that angle A plus angle P plus angle B plus angle AOB, that will be 360 degree, and this will be 90 plus angle P plus 90 plus angle AOB, that will be 360 degree, which means angle P plus angle AOB will be 360 degree minus 180 degree, which is 180 degree. And we will also get angle A plus angle B equals to 90 degree plus 90 degree, which is 180 degree. So what we observe here is this quadrilateral is a cyclic quadrilateral. Therefore, we can say that AOBP is cyclic. And here we can say angle AOB and angle APB are supplementary. So this is what we have in terms of concepts and theorems. Moving towards the problem, we'll be discussing in our next session, where I'll be talking about the problems based on these concepts what we have seen today, and we'll be solving questions based on it. Thank you. Take care everyone.